Okay, Assalamualaikum, guys. So, we continue our application of first order differential equation. Okay, this is last subtopic for application of first order. So, measure problems. Okay, so objective today's students should be able to solve application of first order ODE in growth problem, radioactive decay. Okay, Newton's law of cooling and measure problem. So today we go to measure problems. Okay, so what is measure problem? So this is the figure for illustrate the model of measure problem. Okay, so the situation here is, okay, we have tank with original hole ataupun original mixture is V0, okay, with some quantity of Q0, okay. At the same time, okay, we have quantity B of chemical X entering tank at rate of R1. Okay, dia masuk chemical B, chemical X in quantity B, okay, dia masuk dalam rate R1. Then at the same time, whilst the chemical leaving tank at rate 2 with quantity, so quantity kat sini B, okay, quantity kat sini ni Q over V0 plus R1 minus R2 times T. So kena tolak R1 tolak dengan R2. Okay, if okay, R1 equal to R2, so kat sini tak payah tolak lah, dia jadi kosong kan. So this is equal to 0. Okay, so kejap lagi kita tengok the situation. Okay, so therefore if QT is the amount of chemical in any time t, then QT satisfied the differential equation. So this is the differential equation, dq dt equal to r, dq over dt equal to r in minus r out. Okay, where the mathematical model is B times R1 minus Q over V0 plus R1 minus R2 times T times R2. Dia punya formula is quantity ni, B ni quantity, okay, times dengan rate. Okay, ni quantity masuk, yang ni quantity dengan rate keluar. Okay, so where dq over dt is the difference between the rate at which chemical enters the tank and the rate at which it leaves. Okay, and then from the mathematical model we get our formula. Okay, so if R1 equal to R2, so we have two cases lah. So bila R1 sama dengan R2, dia jadi macam ni je, yang leave tu. Okay, bila dia tak sama, R1 not equal to R2, so macam ni lah dia punya quantity for leaves. Okay, tu je beza dia. Alright, so we go to example. Okay, example. Okay, initially 50 kilo of salt are dissolved into a large tank that holds 100 liters of water. Okay, a brine solution of 2 kilogram per liter is pumped into the tank at a rate 3 liters per minute. Okay, ni rate dia lah, R1. A well-stirred solution is pumped out at the same rate. Sama So kat sini we know that the first case R1 is equal to R2. Okay, fine. Okay, how much salt is in the tank at any one time? B, how much salt is in the tank after 30 minutes? Okay, so keluarkan dulu apa dia bagi. Alright, so given that okay, we know that Q is quantity, okay, quantity in the tank at any time t. Okay, given when t equal to 0, okay, our V0 equal to, V0 apa? Okay, dekat sini kata initial di 50 of salt, 50 kilo salt. So, tu adalah Q0. Q0 equal to 50. Okay, V0 adalah air ataupun solver yang ada dalam tu. So, kat sini apa berapa? 300 liter. Tu V0 tu. Okay, 300 liter. And then, at any time, okay, sebab time dia sama kan. At any time T, okay. So, B is equal to 2 kg per liter sebab dia masuk kan. At rate R1 equal to 3 liter per minute. Is equal to R2 sebab dia kata at the same rate. Alright. Okay, so using terus formula yang ada, so we have dq dt equal to B R1 minus, okay, Q over V0, okay, R2. Okay, so substitute the values. Okay, B berapa? 2. Okay, R berapa? R1 berapa? 3. Okay, tolak Q. Q tak tahu sebab kita nak carilah Q tu. Kan? How much salt? Q lah. Over V0. V0 300. V0. Okay. Darab dengan R2. R2 is 3 kan? Right? Okay, simplify. So, dapat 6 minus. So, ni jadi 100 lah. So, that 1 over 100 Q. Okay. Alright, next. Okay. So, we get dt, dq dt. dq dt is equal to 6 minus 1 over 100 Q. Okay. So, for this okay, macam mana nak buat? Samakan pembawah dia. Okay. Yang ni saya samakan pembawah dia. Become 600 minus 1. Okay, ataupun minus Q over 100. Okay. Alright. So, next. Dah dapat macam ni. Kita tukarlah. Maksudnya, this is separable. dq dt. This is separable punya differential equation. So, dq tu Q letak dekat dq. dt tu letak je dekat sebelah right hand side. Okay, so we get 1 over 600 minus Q dq equal to 1 over 100 dt. Okay, and then kena integrate both side, integrate, so become ln, okay, 600 minus Q over negative 1, okay, equal to ln, pandai je ln, integrate 1 over 100, okay, kita dapat 1 over 100, ni kan nombor, okay, so dia jadi nombor lah, so T, okay, plus C, alright. So negative 1 ni, saya bawa pergi right hand side, so become ln 600 minus Q, okay, equal to negative, okay, 1 over 100 plus, tertinggal pula, T, okay, plus C. T plus C. Okay. So, saya nak buang ln. Saya integrate both side. Okay, so integrate both sides. Saya taking ln both sides, so taking exponent both sides. So exponent ln becomes 600 minus q equal to exponent negative 1 over 100 t plus c. Okay, so next. Okay, saya sambung ke atas. Right, so saya nak cari q tu sama dengan apa. Right, so that we get 600 minus q equal to exponent negative 1 over 100 t, okay, times exponent c. Okay, so we can write as c exponent negative 1 over 100 t. Okay, where our c is equal to exponent c. Okay, so ni 600 tolak q. Alright, so next, pergi pada soalan how much salt is in the tank at any one time. Okay, so the answer is when t equal to 0. Bila dia kata at any one time ni, kita ambil yang Q kita initial lah. Initial ni. Yang 50. Okay. So we have to find the value of C. Right? So when T equal to 0, okay, Q equal to Q not equal to 50. Okay, so 600 tolak 50 equal to C exponent negative 1 over 100 times T. T sama dengan 0 lah. Okay, so ni 0 C lah. So C is equal to, okay, C is equal to 550. Okay. Right. So we get the new equation 600 minus Q equal to 550 exponent negative 1 over 100 T. Okay. So ni yang baru. Okay, so nak jawab B, kena guna yang baru. So B, how much salt is in the tank after 30 minutes? So dia bagi T sama dengan 30. Okay, so berapa Q? So we get 600 minus Q equal to 550. Okay, 550 exponent negative 1 over 100 times 30. Okay, substitute into the substitute all the values, okay, in calculator, and then we get, okay, 600 tolak lah kan. So Q, okay, Q sama dengan 192.55 kilo. Okay, so get here. Alright. Okay. So ni saja. So next, next. Okay, we go to second example. Okay, this is example for not equal. R1 is not equal to R2. Okay. So a tank initially contains 500 liters of pure water at time t equal to 0. Okay, brine containing 2 kilo of salt per liter water is allowed to enter the tank at the rate of 10 liter per minute. Okay, the well-mixed solution is drained off at the rate of 15 liter per minute. Okay, how much salt is in the tank after 15 minutes? Okay, dia nak tanya lepas 15 minit ada berapa lagi mixture of salt dalam tank. Okay, so keluarkan dulu apa dia bagi. So given that, okay, before given kita kena let dulu lah, let Q. Okay, let Q be the quantity, okay, in the tank, okay, at the rate at any time, sebab Q tu QT kan, so at any time. Okay, so given that when T equal to 0, so our V naught is equal to 500, okay, liter, and our Q naught equal to berapa Q naught kita? So dia ada pure water kat sini. So bila pure water tak ada apa-apa lah, kosong kan, dia tak ada salt. So our Q naught is 0. Okay, and then at any time, okay, at any time T, okay, so we have B equal to 2 kilo of salt. Okay, 2 lah, 2 kilo of salt per liter. Okay, 2 kilo per liter is allowed to enter the tank at rate. So kita ada R1 here is 10 kan. Okay, the well makes the drain off at rate R2 is 15 liter. How much? Okay, so kita ada ni yang dia bagi. So we know that our formula is, so dq over dt equal to, okay, B R1 minus Q over V naught, okay, times adalah plus R1 minus R2 times T, okay, times with R2. Okay, so substitute all the values given into the equation ataupun into the formula. So we know that dq dt is equal to, so B is 2 times R1 10 minus Q over V naught 500 kan, 500, okay, minus plus R1 minus R2 is negative 5T, okay, times R2 15. Okay, so simplify, we get 20 minus so ni 3, ni 100, okay, this is 1 lah, negative 1. So we get 3Q over 100 minus T. Okay, so we get dq over dt equal to 20 minus 3Q over 100 minus T. Okay, next we can change ataupun we can separate, not separable lah, we can change the cara kita tulis so become dq over dt, okay, plus 3Q over tak buat 3Q lah, 3 over 100 minus TQ, okay, equal to 20. So this is, okay, linear DE, differential equation. Okay, so kita kena solve using linear DE. Okay, so macam mana nak solve linear DE? Kena cari integrating factor IF. Okay, find IF equal to, okay, exponent of integration of P kan. So what is our P yang ni? So 3 over 100 minus T dt. Okay, so is equal to exponent, integrate 3 over 100 minus T is become 3, okay, ln 100 tolak T over dengan minus 1. Okay, right, so we can write as exponent negative 3 ln 100 minus T. Okay, then we can simplify as exponent, okay, ln, okay, 100 minus T power of negative 3, Okay, and then we can simplify exponent and ln though. Exponent and ln. So we get 100 minus t power of negative 3. Okay, or we can write as 1 over 100 minus t power of 3. Boleh juga. Okay, tapi saya berhenti kat sini lah. Alright, next. So step 2, kita masuk balik. We have d over dt. Okay, our IF IF kita 100 minus t power of negative 3 times dengan q. Okay, equal to 20 times dengan IF. 100 minus t power of negative 3. Okay, integrate both side. So integrate both side. Ini terus dt lah. Okay, integrate both side. We get 100 minus t negative 3 power of negative 3q equal to, okay, bila belah sini kena buat apa? Okay, so letak di bawah lah. So 20 kat luar. Integrate 1 over 100 minus t power of tak bawah pula, tak payah, biar dia kat atas. Okay, so integrate 100 tolak t power of negative 3 is 100. Okay, 100 minus t 100 minus t power of negative 2 over negative 2 kat bawah. Okay, negative 2 plus c. Okay, so next dia become, betul ke? Betul kan? So kat sini akan jadi negatif 10 lah. 10 100 tolak t power of negative 2 plus c. Okay, so that our q is equal to negative 10 100 minus t negative 2 plus c over 100 minus t power of negative 3. Okay, so boleh simplify. Okay, become 10. Apa ni? Negatif 10 bahagi ni 1 lah jadi kan? 1. Okay, that's 10. Negatif 10 100 tolak t. Okay, plus, okay, c dia darab dengan 100 tolak t kuasa 3. Bawa naik Okay, so this is our q. Right, so next tengok at t equal to 0. Okay, at t equal to 0 ni our first ni. At t equal to 0, v not equal to 500 and q not equal to 0. Nampak? So q ni kita ganti dia kosong. Okay, so sebab kita nak cari c. Okay, so kosong sama dengan negatif 10. Okay, 100 tolak t tambah c 100 tolak t kuasa 3. Okay, so that c sama dengan negatif 10 100 tolak t over 100 minus t kuasa 3. Okay, so dia dapat berapa? So ni tinggal kuasa 2 lah. T kita kosong kan? T kosong. So over 100 lah. 100 kuasa 2. Negatif 10 over 100 power of 2. Okay, so dapat negatif 0.001. Okay, so hence, okay, our new equation become, saya guna color hijau so our q is equal to negative 10 100 minus t. C kita dapat tu tadi, so negative 0.001 times 100 minus t power of 3. Okay, then baru boleh jawab soalan how much salt is in the tank after 15 minutes. So dia bagi t equal to 15. Okay, so saya padam sikit ni. Okay, t is equal to 15. Berapa dia punya q? So that q is equal to 1. Okay, sekejap, delete dulu. At t equal to 15, so that q is equal to negative 10. 100 minus 15. Okay, minus 0.001 times 100 minus 15 power of 3. Masuk je dalam calculator, then we get our q is 235.87 kilogram. Okay, alright, so this is the answer. Okay, so panjang kan? So kena tahu kalau untuk R1 tak sama dengan R2, memang dia akan jadi linear. Kalau yang sama, dia separable macam separable biasa. Okay, so okay, so that is for this video. So thank you and see you next video.